Okay, so this lecture we're going to talk about absolute value equations. So we're going to solve equations that happen to have absolute values in them. So as you read this section, there's lots of examples. I'm just going to slowly get to more complex ones as I go along. So let's start out with a really basic one. What if the absolute value of x is equal to 7? Well, remember, the absolute value of a number is just essentially giving you the magnitude of the number, kind of ignoring the sign that's involved. So in this situation, when you're solving an equation like this and you want to get rid of those absolute values, what you want to do is you want to introduce, well, what are the possibilities when I get rid of those absolute values? So forgetting this absolute value means that I'm going to introduce a plus or a minus. I'm going to introduce two possible solutions here. So in this case, I could just put a plus or minus here. So x could be plus 7 or minus 7. And that's the answer. X could be either of those. Because if x is plus 7, the absolute value is 7. And if x is minus 7, then the absolute value is also 7. I'm just talking about the magnitude there. Okay, so let's look at a more complex situation. So suppose that we had the absolute value of a plus 2 is equal to 7 over 5. So how would we solve this? Well, if we want to drop that absolute value and just have a plus 2, well, then we're introducing two possibilities. You either are going to be plus 7 over 5 or minus 7 over 5. So plus or minus. So to solve it at this point, what I would suggest is we're going to try to solve for a. So we actually have two equations that we're trying to solve, right? A plus 2 is equal to 7 over 5. Or a plus 2 is equal to minus 7 over 5. Okay, so we're practically there. Let's just isolate the a. So how do we do that? Well, we're going to subtract 2 from both sides, and we'll get our a, right? So 7 over 5 minus 2, right? So so what will this be? Minus, right? You remember, you know how to do this by hand, right? So 7 over 5 minus, you would find a common denominator. So minus 2, I'm going to have to make a denominator of 5, so I'm going to have to multiply this by 5 over 5, right? 5 over 5, get negative 10 over 5, so that'll be minus 3 over 5. Okay, so that's one of the solutions. A is minus 3 over 5. Okay, and you could check that. You could come back up here and check, is that a legitimate solution? And if you plug that in, you'll add 2, and that will be 7 over 5. Okay, how about over here? Well, you're actually going to proceed the same way, but we want to separate them because, well, in the end, you're going to get a solution that you should check, because there are situations that you get a solution and it might not actually be a solution. We'll talk about that in a little bit. But also, separating them, it takes away from the confusion of having to deal with a plus or minus and possibly making an error that you don't want to make. So subtracting the 2 now. So minus 7 over 5. And if I subtract 2, I'm going to be subtracting 10 over 5, right? Finding common denominator the same way. So a would be minus 17 over 5. And that will be the other solution. Okay, so since I'm boxing these, those are both legitimate solutions, and you should check that. If I add 2 to this, right? So I'm adding 10 over 5, so that would be negative 7 over 5, but I'm taking the absolute value, and that'll give me 7 over 5. So these are both solutions. Okay, so continuing, let's try to solve this one here. So if we want to drop the absolute values, we can do that. 4 over 5x minus 5, but then we're going to have plus or minus 15. So we have two different equations to deal with here. So 4 over 5 x minus 5 is equal to the positive solution, or 4 over 5 x minus 5 is equal to minus 15. So trying to solve for this, we just use our same techniques that we've always been using. So add 5 to both sides. We're going to get 4 over 5x is equal to 20. We're going to have to multiply both sides by 5, and then we'll divide by 4. Alternatively, you could actually multiply with the reciprocal of this. You can multiply both sides by 5 over 4, and that'll reduce that, and then 5 over 4 here. But either way, you'll get the same solution. So if I multiply both sides by 5, we'll get 4x equals what? So that'll be 100, and then divide by 4. Oops, computer thought that turned into a 9, but that was a 4. So 4 divided by 4. So x is 25. And we could check that solution real quick coming up here. 25 divided by 5, right, is 5. 5 times 4 is 20. 20 minus 5 is 15. Absolute value of 15 is 15. So over here, what I'm guessing is we're going to get negative 15 from this solution, right? I mean, that's what we're solving for. We're solving for x. 4 over 5x minus 5 equals negative 15, right? Because the absolute value of negative 15 is 15. That's why this is legitimate procedure. So adding 5. Okay, so we'll have 4 over 5 x is equal to, in this case, minus 10. And then what will we do? Well, same thing, right? You multiply by 5. Then we'll have 4x is equal to minus 50. And then divide by 4. Well, what are we getting in this case? So what are we getting? Well, 50 divided by 2 is 25, and then 25 divided by 2 would be, so this would be negative 12 and a half, right? 12.5, right? Multiply by 4, you get 50, right? Multiply by 2, you get 25. Multiply by 2 again, you get 50. So that should be the other solution. And if we substitute that in up here, right, we're going to get negative 15, and the absolute value of that is 15. So this is right, so x is either this or x is this. Okay, can't be both, but those are both legitimate solutions. So if you wrote the word and, it's not, you know, I'm not going to take off a point for that, but x is one or the other, and those are the two solutions. Okay, so continuing on, let's say that we had this here. So 3x, absolute value of 3x plus 1 is equal to 4. So if we want to drop those absolute values, we'll have plus or minus 4. And try to, well, we should separate them, right? So there's two separate equations here. So 3x plus 1 is equal to 4, and 3x plus 1 is equal to minus 4. So subtract 1. We'll have 3x is equal to 3, divide by 3, and we'll have x is equal to 1. So that's one of the solutions. You can check that real quick. 3 plus 1 is 4. Absolute value of 4 is 4. So over here, subtract 1, we'll get 3x is equal to minus 5, and then divide by 3. So x is minus 5 over 3. Right, so those are our two solutions. And you could check that real quick. You'd have minus 5 plus 1, which would be minus 4. Absolute value of that is 4. Now, another thing you want to be careful of, just to throw this in there. What if, let's say, I give you this other example. Let's say that I changed this. So it said 3x plus 1, but instead of 4 is equal to minus 4. Well, if you try to use the same procedure that we've been using all along, pretty much just said, oh, well, we'll throw out those absolute values, and then you'll have plus or minus the thing that's over here, right? But that's a problem because what's happening here? Well, you're taking the absolute value of something. And when you take the absolute value, you are always going to get a non-negative. You're either going to get 0 or you're going to get a positive value. And so it's impossible to take the absolute value of something and get a negative number. So how do we denote this? Well, there's no solutions. No solution. Absolute value is always non-negative, right? Meaning it's impossible for it to be a negative value. Okay, so the set of x values in that case, we have a special notation for that, right? No solution, no x value that'll satisfy that. And the set, the way that you denote that is like this. This is called the empty set. Empty set, right? It's the set that has no elements. So another way to denote that would be the squiggly braces, and you'd have nothing in there. So the empty set is the set that has no elements. Okay, so that's not 0, right? So some people like to write 0 that way, but that's notation that's designating the empty set. Okay, so let's continue and solve some other ones. All right, so here's an interesting example. Let's say that you had 2 plus absolute value of 2t minus 6 is equal to 10. Now, you see, before you drop these absolute values, you really want to have that expression isolated on one side so we can drop them and have the plus or minus to the other side. So let's do that first. We're going to isolate the term with the absolute value. So we're going to bring the minus 2 over. And what will we get here? So we'll be left with the absolute value of 2t minus 6 in absolute value is equal to 8. Okay, and now we can proceed. Now we don't have a negative over here, so this is actually possible. You can have the absolute value of something equal positive 8. So we'll have 2t minus 6 is equal to plus or minus 8. So at this point, we're going to have two equations that we're going to try to solve. So 2t minus 6 is equal to positive 8, and 2t minus 6 is equal to negative 8. So we will add 6 to both sides, and we'll have 2t is equal to 14, divide by 2, and we'll have t is equal to 7. And over here, we'll pretty much solve it the same way. We'll have 2t, but this time it'll be negative 2, and so dividing by 2, we'll have t is equal to minus 1. And we could test our solutions real quick. So if I plug in 7 here, 14 minus 6, right, absolute value of 8 plus 2 is, so 2 plus 8 is 10, right? And then over here, negative 1. So if I put a negative 1 here, that'll make this a negative 8, but the absolute value of that is 8, and 8 plus 2 is 10. So see? All right, so now let's look at quite an interesting situation. So see, we have two expressions that have absolute values. They're already isolated. So what happens when we get rid of them? Well, using the same technique as above, we can drop the absolute values and we'll introduce a plus or minus into the situation. So if I drop this, right, I'm going to introduce a plus or minus, but there's no need to, put, we can just immediately go to plus or minus without the absolute values. Okay, so we have two equations at this point. We have y minus 5 is equal to y minus 4, or y minus 5 is equal to minus, and here's where you got to be careful, right? That minus is going to get distributed. Okay, so let's solve these. Well, here's where something interesting happens, right? So if I subtract this over, if I subtract y over, right, we're trying to isolate it, what are you left with? Well, minus 5 is equal to minus 4. Well, that's definitely a problem, right? That's not possible. So this equation leads to no solution. And then what happens over here? So we have y minus 5 is equal to minus y plus 4. All right, so it seems at this point that this one actually might be possible. So let's see what happens. Well, we're going to add this y over here to the other side. So we will add y. And at the same time, we'll bring this constant over here. So we'll add 5. Okay, so on this side, we'll have 2y. 5's cancel. Right? The y's cancel. And we get 9. So it looks like the solution would be 9 over 2. Right? Now, here's where you have to be very careful. Right? Immediately, you might think, oh, let's box that. But let's come up here and actually see what would happen. Is that really a solution or not? Okay, so you need to really check. Okay, the cases that we have to check are especially these ones, the ones where we have multiple absolute values. Things can go wrong here. Okay, so if I plug that in up there, well, what do you have? Maybe before you even plug in, you could see something's going to be, there's going to be probably an issue here, right? But maybe not. We have to check. Okay, so if we do 9 over 2 minus 5, what is that equal to? So that'll be the absolute value of 9 over 2 minus 10 over 2. And that's the absolute value of negative 1/2. And that's a half. Okay, so that's what the left-hand side would be. What happens if we simplify the right-hand side? So 9 over 2 minus 4. So there we would have 9 over 2. Okay, 9 over 2 minus 8 over 2, right, to find a common denominator. So then we have 1/2. And the absolute value of a half is a half. So these actually are the same. So what that means is this is actually a solution. Okay, so yes, y equals 9 over 2 is a solution. All right, and it's a good habit to do these quick checks, especially in these types of situations up here. Something could go wrong. That's why you got to check.